Come on, come here, bud. Come on.
G'day everyone, welcome to another Toolbox Tech Talk. Yep, it's that time of the week again, and yet again, DJ Glemmo couldn't make it, so the boss has to fill in for him. But we continue this really interesting series of interviewing people from the broad spectrum of renewable energy and associated industries. And today, my guest is Jason Venning. He's the Director of Commercial and Infrastructure for eLumina. So let me just bring him on. Okay, Jason, g'day.
Hi, Glenn. How are you?
I'm good, and yourself?
Yep, extremely well.
So you're in sunny Melbourne, I believe.
Look, I am actually, and believe it or not, I can see out my window in front of me, and it is sunny, so we're in luck. It's one of our good days.
One of our good days. We've got to count them on one hand, that's right. So, Jason, just for the audience who may not have heard of eLumina, tell us a bit about the company.
Yeah, look, for sure. So the company was founded a bit over 2 years ago now, and there were three founders, and one of them who's now our CEO, Lisa Marsh. So she was doing consulting for a number of years in China, sort of helping Chinese businesses who wanted to develop battery storage technology that's sort of suitable for overseas markets, and one of those markets was Australia. And she came into touch with the other two founders, Chris Yang and Ethan Tian, in her travels, and together they identified that they could see a good use for batteries to support electric vehicle charging. And they saw that Australia had some, well, I won't maybe unique, but let's say some quite difficult challenges in terms of rolling out EV charging due to our geography and sparse location and all those sorts of factors. So I thought, okay, well, let's form a business here in Australia and let's focus on batteries supporting electric vehicle charging as our sort of primary entry into the market, because they saw a gap there, and have spent the last 2 years having quite a bit of early success and really gearing up to deliver that in that market.
So why do you need a battery to charge an EV?
Well, a very good question. The issue is with electric vehicle charging, for those not living in urban areas, or for those where they're in areas that the grid supply is not very good or very strong, it really limits the possibility of using particularly fast charging, because these direct-to-grid chargers, as they're called, I mean, they need a lot of power to make them run, because obviously if you're pumping 200 kilowatts into your vehicle to charge your battery, then that 200 kilowatts is going to have to come from somewhere, and that's a lot of energy that most places don't have lying around just waiting for an EV charger to be connected. So,
but doesn't the battery need then a 200 kilowatt supply to recharge?
Well, that's the good thing about the battery, because it doesn't. So essentially the battery acts like a booster. So you can actually take a much lower power input and use that to essentially trickle charge the battery, and then the battery boosts the available AC input supply to give you a much faster rate of charge. So if you can imagine the scenario where, say, you've only got 10, 20, 30, 40 kilowatts of power available, which is not beyond your average sort of commercial industrial premises, for example, you can use that to charge the battery, and the battery enables you to take that 40 and turn that into 160 or 250 or even 400 kilowatts of charging power, while the battery has got capacity in it. So really it's a booster, and that's the magic there, so of using a battery.
I can see it now. It's just a bit like a rocket ship filling up slowly with rocket fuel, but then boom, off it goes.
Yep.
So you're filling up with the rocket fuel of electricity at a slow rate, and then delivering it straight into the EV at a high rate. Exactly.
And that allows you to deliver high-speed charging over a period of time. Obviously, that's dependent on the capacity of the battery, but even when the battery is depleted, essentially you're still falling back on your AC input. So your charger will always have some energy to charge. It'll just be going from high speed down to lower speed, depending on whether the battery is depleted or fully charged.
Actually, I was watching a video from fellow Australian YouTuber Engineering with Rosie, and she was saying one of the challenges for like transport using, EV powered trucks is that there's not the capacity to charge them at most stations, but you could provide that capacity with this shifting of when the energy is being stored and when it's being released.
That's right, exactly. And I mean, this type of application is really good for fleet applications where, let's say, you've got vehicles going out and coming in on sort of a regular routine type interval. So you might have trucks charging overnight, and then they go and do their runs, and they might come back once or twice during the day for a bit of a top up. And that gives the battery enough time to charge sufficiently so they come in, get a quick charge, off they go again, and then the battery can replenish itself in the meantime. And at night, when, well, in theory, if it's not a 24/7 operation, the battery can charge off what presumably would be lower cost energy to be ready to start the whole process again the next day. And really, the size of the battery can be scaled up to almost anything you want, to suit how many vehicles you want to charge, the frequency of the charging, and the speed of the charging. So the products we're talking about today, I mean, they're targeted at, let's say, commercial, industrial, smaller type fleet logistics operations with a few vehicles. But if you were to have a much bigger battery, well, that really just scales up what you can do, your throughput and the number of vehicles you can handle quite significantly. So it's very scalable technology, just with the same concept.
Yeah, I was looking at eLumina's website before we went online, and I saw that you've got two major products, the D3 and the DS400. Tell me about the D3.
So the D3, I suppose, just a little bit of background. So our original product, which is going to be replaced by the D3 next year, was called the D1. And essentially that was a battery integrated EV charger. So has a battery, in that case it was 193 kilowatt hours of capacity, and you could run that unit from anywhere between 10 and 40 kilowatts of AC input. So for the electrically minded amongst the audience, I mean, essentially that's 16, 32 up to 63 amps, three-phase, that you can use to run that particular unit. And that allows you to get up to 160 kilowatts of charging power on a single connector, and then that could be shared across two connectors if there was more than one vehicle. So that was the D1, and we've had quite a lot of success with that unit, rolling it out with customers like NRMA, Essential Energy, for example. So that's got quite a bit of traction in the marketplace. So where the D3 comes in, let's call that the next generation of this product. So this adds a number of interesting features that would be of extra benefit. So one of the main ones being a bidirectional input. So what I mean by that is essentially, yes, you can charge the battery and power goes in to charge the battery, but then if the battery has power available, you can actually push that power out in the other direction to potentially go back to the grid or to power a load that is attached to the same AC distribution network. So that's quite a big difference from the original D1. And the other is a boost in the maximum charging power. So instead of 160, now you can have up to 250 kilowatts across two charging guns in the one unit.
I think you just invented a new acronym, B to G and B to L. Have you heard of those?
So yes, we like that. So the other one I think we've invented it, we'll claim it anyway, is BIECV, or Battery Integrated Electric Vehicle Charger. So hopefully you'll hear a lot more of that term. Yeah, B to G and B to L, so battery to grid and battery to load, as we're calling them.
I do have one concern. What happened to D2?
D2, well, there is actually a D2, because we do have a range of direct-to-grid chargers. That is just normal, traditional fast chargers without battery. So they actually are our D2 range. And if you were to need a much bigger battery than is in our D3 and DS400, for example, we could provide a standalone battery coupled with a D2 charger to give you similar functionality, but at a much larger scale.
I've got a product suggestion for you. How about calling it the R2, which is the renewable 2, D2?
Yeah, yep, I like that. I'll definitely take that one on notice for future.
R2D2. Yep, you'll get a few fans from Star Wars for that one.
That's right.
So I've read that these things are liquid cooled as well. Why is that?
Well, batteries to perform at their best need to be kept at within a certain temperature range. And air cooling is fine under certain applications, but really in particularly hot environments, like a lot of parts of Australia, for example, to achieve that constant temperature to keep the batteries cool and performing at their best, you need to have a liquid cooled system. So, operates on a similar principle to a fridge, for example, or any other sort of air conditioning device that uses sort of liquid cooling type arrangements. So, heat exchange type of situation. And in the case of these products, it's fully self-contained. So there's no sort of external pumps or motors or any other bits and pieces that need to be added on or installed to make it work. It's all fully integrated within the unit. And it just keeps the battery cells and modules nice and comfortable and allows them to maximize their ability to charge and discharge without overheating.
So this is a freestanding modular design delivering 250 kilowatts of ultra-fast DC charging.
Yep, up to that, yes.
Up to 70 kilowatts of grid input, three-phase. And I think you said 175 kilowatt hours of storage. Is that right?
Yes, that's right, in the D3. So slightly smaller battery than the D1, but effectively giving you engineered in such a way so you can actually boost the output charge even more than our D1.
Right. Now you've got the big boy, the DS400. Tell us about that.
So the DS400, let's say that's for targeted really at larger vehicles. When I say larger vehicles, could be physically larger vehicles, but particularly vehicles with higher battery capacity. So if you're going into electric buses, coaches, trucks, you're going from, 70, 80 kilowatts an hour, and you're going to hundreds of kilowatt hours in terms of their battery capacity. So for them to travel a similar distance to a car, you're going to be pumping quite a lot more energy into a much larger battery. So the DS400, very much the same principle as the D3, just it has a double the size of the battery, 350 kilowatt hours in this case. And that allows an output of up to 400 kilowatts. So boosting the capacity of the battery so you can fill a vehicle with a big battery from a single charge or a top-up, multiple top-ups from the same battery. And the higher power suits these bigger vehicles which can charge at much faster rates than the average passenger EV in today's current market. So let's say the D3 is targeted to maybe commercial and industrial businesses, small regional fleet outputs who might have a few vehicles that they need to power. And then the DS400 really allows you to step up to larger trucks, so moving into the mining sphere and heavy haulage and other areas where the vehicles are bigger and the battery capacity that's required is larger, and they need less time sitting around charging. So a faster charging speed is also of a big benefit as well.
So do they charge faster than 70 kilowatts?
Well, the 70 kilowatt input is still the same, just with the larger battery. It's able to boost the power even higher. And another difference with the DS400 versus the D3 is the battery technology. So for the battery people out there, they'll know what I'm talking about. I'll try and explain it as best I can without too much jargon. But batteries have different, let's say, rates of charge and discharge, if you like, depending on how they're configured. So most batteries these days, and I'm talking commercial type batteries, they're known as what it's called 0.5C. So 0.5C, C just means reflection of the rate at which they can charge and discharge, or the amount of current that can be used to charge and discharge them. So you might have heard terminology like half-hour battery, 2-hour batteries, 4-hour batteries. So that's really just saying, okay, if you're charging or discharging this battery, this is how long it will take to do that. So a 0.5C battery would take 2 hours to fully discharge, whereas a 1C battery like in the DS400 would take 1 hour to fully charge or discharge. So you've got all that energy stored. Effectively, it means you can push that energy out at a much faster rate, and hence that also supports the ability to go up to 400 kilowatts in output power for charging. So hopefully that makes sense.
So how do you achieve a 1C rating using LFP batteries?
Well, it's just a variation of the existing technology. So higher ability to higher rate of charge and discharge. So essentially just modifying the configuration and the pack sizing and pack orientation, if you like, of the batteries to allow that higher charge and discharge rate. So it does mean that the battery's working harder, but with LFP technology as well, you can do that and still get a very, very good number of cycles or lifetime out of your battery. But with the 1C, again, you're going to generate more heat because there's more current going in and going out within the same amount of time. So the liquid cooling technology, again, is even a step up on the D3 to keep that all working nicely.
Yes, liquid cooling, that's your secret sauce. So I'm just thinking about the charging times. So for the DS400, charging at 70 kilowatts for a fully empty battery, it would take about, 5 hours?
Yes, that's right. So yeah, if we're going from flat to full, it would be about 5 hours. Generally, these products, they'll have a minimum state of charge, so they'll go down to maybe 10-15%, just to make sure there's enough juice left to keep the actual battery running, and in case the AC input goes off, it can keep itself running and shut itself down in an orderly fashion. So effectively, you're probably using around 80 to 85% of the actual full battery capacity. So yeah, you're looking at a charge time of, let's say 4.5 hours roughly from minimum to full.
Right, and then you could discharge in nearly an hour.
That's right.
If you had a big enough customer who's plugging in, and then get another charge again. So basically twice a day, you could cycle that system fully.
Yeah, exactly. So I suppose I should point out that these products, they're not designed for extremely high frequency use because obviously ideally the battery needs time to top itself up in between charges. It doesn't have to be fully charged, but to make sure it stays above that minimum state of charge so it can provide that maximum charging output for as long as possible. So that's why, again, it's good for fleets, buses, premises where vehicles are coming and going at various fixed times of the day, and there's time in between for the battery to charge itself up again, so it's ready to deliver the fastest possible charge and the most energy to the vehicles when they come in. So it sort of really fits that kind of frequency well, but it's not like you wouldn't put it in a public charging space where cars are turning up several times an hour, and obviously that would soon deplete the battery and you'd fall back on whatever AC input supply you had.
Yeah. So I was just looking also at the specs on your website. It says it has the DS400 has a built-in EMS for optimized renewable integration. What does that mean?
Well, one of the other things that the D3 and the DS400 can do is they can actually accept direct DC coupled PV input. So let's say, particularly like picture a sort of regional remote area, You may not have a very strong grid connection. You might be on a microgrid, for example. And so you could actually have a solar array or part of the output from a larger solar array and take some of that direct DC coupled input from the PV array into the D3 or the DS400. And that would also contribute to the charging of the battery and also the total power available for output charging. So what you can do with both these products is you can have a combination of direct DC coupled PV input and AC input, or you could have 100% PV input. So it's just a question of having the right module. So you've either got an AC-DC converter on the input, one or two of those, or you've got a PV MPPT input, one or two of those. So it's actually very suitable for off-grid applications because it can have that direct coupled PV input. So that's where the renewable integration comes in. So if you optioned one of these products and you wanted to use 50% or 100% input from solar, then you could. And the EMS, the role of the EMS, or in that case, is to make sure that it's maximizing the amount of renewable energy that is being used to charge the battery versus what's coming from the grid supply, just to make sure that you're maximizing your renewable penetration.
So if you're charging from photovoltaic sources, what's the maximum charge rate you can do?
So you can do up to 40 kilowatts of on the input from solar, or 80 kilowatts input from solar if you're using two input modules, and this is the DS400 I'm talking about in this case. So with that, you can still get your 400 kilowatts output charge on the DS400. So the principle remains exactly the same, just the MPPT modules in the DS400 or the D3, they're managing the variability in the solar input and smoothing that out for the charging of the battery so that you can still have that constant output charge regardless of what the solar is doing. So the electronics inside the charger are smoothing out the peaks and the troughs just like a standard solar inverter would do, and giving you a constant output whenever there is PV on the input.
Can you combine both AC and DC charging at the same time?
Yes, so the solar and the PV, the solar PV and the traditional AC grid, yes, you can. So you can have 50-50. So half your input comes from the AC grid and half comes from PV. And you can do that on both the D3 and the DS400. So you do have that option of still having the grid as a fallback, particularly if you're running at night time and obviously the sun won't be shining and you still want to be able to recharge the battery for the next day.
Wow, cool. That's great. So two MPPTs on the DS400 and the D3. What's that got?
Yeah, exactly the same. So the only difference with the D3 is that you can have one MPPT module rather than two. So you always have one MPPT and one grid input, or just two grid inputs. So one 35 kilowatt solar PV MPPT and one 35 kilowatt AC/DC, or the other combination is two 35 kilowatt AC/DC. So the D3 is not intended to be sort of fully off grid, whereas a DS400 can be.
Right. So do you have like a backplane that you can plug these modules into to suit the application?
Exactly. So the whole units themselves are set up in a very modular way. So the battery packs, the cooling systems, the PCS or power conversion system or inverter, another word for the same thing, battery management systems, they're all modular. So they just pull straight out of the back plane of the unit. So you can open the cabinet doors, pull out the relevant units and replace them as required. So the actual PV and DC modules on the inputs, you need to sort of specify those when you order the unit, because there is some additional work that needs to be done to configure the backplane for the PV versus the straight AC/DC. But in terms of once you've got the unit, if you had a problem or if you needed to replace something, it's very easy to do because you can just take out the relevant module and replace it with a spare.
Oh, very nice. Now, everyone's concerned about safety when it comes to batteries. What features do these units have?
So both units have got what we call an aerosol fire suppression system. So the idea there is that essentially you have a sensor that can detect a rise in heat inside the unit, which could be an indicator of the start of a thermal runaway event in the battery. It can also detect smoke or other factors like that may indicate there's a problem. And then once it reaches a certain threshold, the unit activates this aerosol, which essentially is chemically based, but using a thermal type reaction, it then converts the chemical reagent into a gaseous form, which then releases throughout the unit, and within sort of 13 or 14 seconds, you've sprayed all of the aerosol over the batteries, and that's enough to extinguish any potential fire or other issues that might be occurring inside the battery. So both the units have that feature in common. So they're very safe from that point of view, and they all have sensors both internally for remote signalling and also externally for visual or audible alarms so that people know what's going on. And they're all designed to prevent essentially fire or any sort of explosive damage getting out into the external environment. So they're built to withstand these sorts of forces so they can contain any explosive forces or other things that may happen under extreme circumstances. And with the DS400, I mean, it goes a step further. It's got an overall fire suppression system for the whole cabinet, but it also has a battery pack level fire suppressant system as well. So it's kind of got a double layer there of protection. So we understand that one of the main concerns of people is about battery fires because rightly or wrongly, people see that, that's a risk versus, other sources of potential kinetic energy like that. So we want to make sure that we highlight the fact that these products are very safe and they've got the latest in technology to minimise the chances of any catastrophic failure of these units.
Well, that sounds really, really comforting. So, many facilities are a little bit capacity constrained, and so they're looking at, do we upgrade our connection to the grid so we can run some fast DC chargers? How does the price comparison work? Is it, cheaper to actually just put in a battery?
Look, it certainly can be, Glenn, and that's one of the other benefits. So grid connection upgrades have got two possible downsides. One is cost and the second one is time. So the cost can be in the hundreds of thousands of dollars, and the time could be, we're talking potentially 1-2+ years, depending on the backlog of work that the local electricity utility's got doing everyone else's grid upgrades, including their own work. So you've got a time issue and you've got a cost issue, and time is worth money, obviously, as the saying goes. So there is a significant cost involved with that time. So if people want to go on an electrification journey and start with that, well, doing a battery integrated charging type scenario really allows them just to get on with it. So they might want to say, okay, let's buy a bus or a coach or a vehicle and let's try it out and see if this is going to suit our requirements before we commit. So for, relatively speaking, a much lower cost and, almost no time other than the time it takes to deliver the product, they could get a D3 or a DS400, very easy to integrate into their existing infrastructure on site, and they're ready to go. So it's really got a lot of advantages for those reasons.
Yeah, I actually heard of someone who bought some machinery discovered that it drew more than their supply could deliver. They contacted the DNSP for an upgrade, and they'd have to upgrade the transformer, which meant they'd have to shut down the whole commercial site for all the customers, which is a major inconvenience. And the cost was just ridiculous. So absolutely a cost saving. But you got me thinking now, if you've got this battery that can do B to G, I love that term. I mean, it's going to earn you some money, isn't it? If you can start to integrate with the grid and do some arbitrage.
Yeah, absolutely right. So, I mean, that's really one of the things why we wanted to introduce this bidirectional feature into the D3 versus the D1, and also when introducing the DS400, because there's definitely benefit in that. So rather than the unit just sitting there and being another cost, then potentially you can improve your return on investment, or at least accelerate it, by being able to do a bit of energy trading on the market, because there's providers out there who can aggregate multiple assets from different sites. So it's not like you have to have a gigantic battery to meet the minimum requirements for doing energy trading. You can sign up with a VPP provider or other type aggregator platform, and they can buy and sell energy from your battery, and you can tell them when you want it to be available, how much energy they're allowed to use. And so when it's not charging, you can, if you want to, monetize it and make a bit of revenue to help, as I said, offset the cost of the hardware in the first place.
Yeah, I mean, I guess for many commercial sites, the weekend it's sitting there doing nothing. Maybe part of the evening it's doing nothing, so it's available for a bit of arbitrage.
Exactly, that's right. So there's other benefits to having that bidirectional feature, which is why we feel quite strongly this adds to the appeal of these products, aside from their core use, and sort of sets us apart from, I'll say, somewhat limited, competitors who offer a similar type of product at the moment.
So what are some real-world applications that your products are being used in at the moment?
Yeah, so look, I'll give you a few. I mentioned sort of at the top of the show, we've been doing work with NRMA and Essential Energy. So there's a couple of examples there. So NRMA, they're the sort of road organisation or automobile organisation in New South Wales, but I mean they do operate in a lot of different states, particularly through their EV charging network, and they needed some chargers that could run on very low power, and they had tried their hand at battery integrated charging before at a few sites. Unfortunately, that product was withdrawn from the market, and so couldn't be supported anymore. So they were looking for a solution. So we had the D1, and that was one of the first contracts that we got when we were established. So NRMA ordered a bunch of D1s, which have gone out into a number of different sites and locations, from very remote to areas that are not so remote, but just don't have the input power to support a direct to grid charger, but people can still come along and charge their car and get a genuine fast charge from very little power. So that's one very good use case. Essential Energy, we've worked with them installing the D1s at their depots for their trucks. So their trucks are coming in at the end of the day and they're charging them. And also, if they're going in and out, they can come in and drop in for a fast charge as well, so they can get back out on the road. And one application that I did want to mention, because we're particularly proud of this, over in Western Australia, there's a very long stretch of road called the Great Northern Highway. And it runs from essentially just a bit north of Perth all the way up into the Pilbara region of Western Australia. So we're talking about a road that's about 1,400 kilometres long. And there's towns and roadhouses and places along the way, but as you could imagine, very, very remote. All of them are off-grid. They're all running on diesel generators. There's really no way for someone to be able to go up any part of that road in an electric vehicle, because there is nowhere that they can get a fast charge or possibly even any sort of charge. So to sort of go with our goal of trying to provide charging infrastructure for regional remote areas, we are putting the D1 or the D3 in at 6 sites along this 1,400 kilometre stretch of road. So people can come along and know that they can go and get a fast charge wherever they need to stop along the way. So it's really one of the things we want to do is just to facilitate the expansion of the charging network and availability of charging, so people in these remote areas don't get left behind. And as you can imagine, these people are thinking, what do we need this EV charging stuff for? But what's wrong with diesel is their sort of viewpoint, which is fair enough. So you just got to say, well, we're trying to create the future here or get ready for the future. And they can benefit from, earning a bit of money for their site. And the other interesting benefit for sites like that is typically these places have a roadhouse where you can, buy your fish and chips or your fried food and that sort of thing, but they don't know what to do with the used chip oil. So for some of these sites, we're actually supplying the charger with a biodiesel generator. So they take their chip oil from the roadhouse, put it in a reservoir, it feeds the biodiesel generator and keeps the battery in the charger topped up in between charges. So essentially it's, even those chargers are fully off grid and supplied by, well, let's say renewable in inverted commas source. So it's solving a problem and providing an extra functionality in terms of the EV charging, and all it needs is some used chip oil to make it work. So just some pretty cool examples like that, and we're very pleased to be doing some of this type of projects around the place.
It sounds a bit like Doc from Back to the Future with his flux converter, popping a few cans in it and
That's right.
recharging his car. Yeah,
Exactly.
using a waste material. Mm-hmm. That's cool. Hey, I'm mentioning NRMA. You just remind me, I actually had that very experience. I was in Broken Hill and the power went off, and I've got an EV, and I was sitting in front of the NRMA's charger, and of course it was off.
That's right.
And I needed to get to Mildura, 300 kilometres away. So
okay.
I really would have done well with a D3 unit there to give me a little top up.
Absolutely right. So again, they're good for those situations where there's no grid, because if the power goes off, the D3 will still run itself, and as long as there's power left in the battery, it will still charge until it gets to that minimum state of charge. So they can operate in a when the lights have gone out, they can still provide some charging for people.
So have you got any deployments for like heavy vehicles? I mean, there's not much heavy vehicle EVs yet, but have you had any chance to interact with them?
Yeah, so what we've done is we've done some testing with a company called Windrose. And so they're a Chinese EV truck manufacturer, and they've been quite successful in launching that product into the New Zealand market first. And now they've launched their latest truck into the Australian market. So we did an initial trial with them at our headquarters in Yatala on the Gold Coast, where they brought the truck in and we tested it with our D1, the precursor to the D3, and validated that it worked well with the Windrose truck. And we've now doing a trial with PepsiCo. So PepsiCo, who own the Smith's crisps brand, or Smith's chips, I should say, they've got one of our D1s at the moment, and they're trialling it to charge this Windrose truck as a bit of a demonstration to see, okay, do we want to buy these trucks, and how we're going to charge them without having to, again, do a lot of grid upgrades at our site. So at the moment, there's a 2-week trial where the Windrose truck is going from Tingalpa to another location somewhere on the Sunshine Coast, whose name escapes me, with a truckload full of Smith's chips, and they're going out to do a run there and coming back, and then charging at the Smith's chips factory with our D1 charger. So we're certainly trying to engage very much with heavy vehicle manufacturers, and also with large industrial users to help them understand how it's going to work for them.
It's kind of funny. Chips must be one of the lightest loads you can take on a truck.
Yes. Well, there's method behind that. Absolutely, Glenn. They're thinking, all right, well, let's not dump something extremely heavy. Let's see how it goes with a light load,
Yeah.
and as a bit of a proof of concept.
Yeah, cool. So maybe just in terms of the product's warranty and support, can you tell me a bit about that?
Yeah, absolutely. So the product warranty, essentially with the products themselves, we got standard warranties. At the moment, it's between 2 and 5 years, depending on the product. And so that's essentially, we provide a sort of remote monitoring service, if you like. It's not sort of a paid service, but essentially through our cloud-based backend, we can monitor our units out there if they are connected to the internet, and we can just see if there's any major alerts or alarms coming up, and then we can call the asset owner and say, look, we've seen this. You might need to do this, this, or this to prevent any major problems happening. Or we can do things like push firmware upgrades if there are new features or improvements that are added to the products from time to time, or if there are bug fixes that should be rolled out to sort of keep things running smoothly. We can do that as well. And then we can supply spare parts. So the standard covers all of those things. And then we're currently developing our warranty plans for these new products, and likely potentially offering an add-on service where we'll provide on-site installation and removal of any parts that have failed or need replacement. So we'll have sort of probably a couple of different levels of service offerings, and we've seen that's quite common in the charger market. So we're trying to, at least offer something that's comparable to what people would expect from a traditional EV charger, but also being Australian based and having our headquarters here and local staff here with the technical capabilities, we can provide a better and quicker level of support than potentially some others might.
Yeah, good. Well, looking into my crystal ball, or maybe looking into your crystal ball, where do you see the sort of EV roadmap going over the next 5 years, and how will battery integrated charging fit into that?
Well, I mean, there was a presentation I attended some months back, and one of the things that was highlighted was there was, as they called it, the 70 or 80% of the easy to do stuff in terms of EV charging. So metro areas, urban areas, where you've got plenty of power, you've got places you can put chargers, and let's say it's relatively straightforward. And if you're going to install chargers there, you could make some money out of them over time. Then that leaves the 20 or 30% in the too hard basket. So that's pretty much most of rural or regional Australia, or areas where potentially a traditional charge point operator just couldn't see a return coming from installing assets in certain locations. So for us, for our future, a lot of that's going to be about servicing that 20 or 30%. So looking after these rural and regional locations where they've got weak grid supply, might not be particularly economic if you were just a charge point operator trying to get in there and make revenue out of putting in charges. But I mean, everyone's got to have an equal chance to get access to this sort of infrastructure, because I strongly believe that electric vehicles can and will be the future for transport, as one of the ways we can reduce our overall emissions in our economy. And so you can't have people being left behind. So in urban areas, it's people in apartments and who don't have driveways for off-street charging. That's something that needs to be addressed for them. But in rural and regional areas, there's sometimes not the power available, and certainly right now there's not the money to be made that would attract a lot of people to go and put chargers out there. So we're trying to do our bit to support that and support getting the 20 or 30% in the too hard basket, and making sure that those people and communities are not left behind in this in the infrastructure rollout for electric vehicles.
I imagine even apartment buildings, because often they are capacity constrained, and there's just not enough for a fast charger.
Yeah, exactly. So, I mean, certainly there's a potential use there as well. Absolutely. So, be more than happy to look at those applications too. But then, obviously, apartment buildings, they've got their own challenges with body corporates and so forth. So that makes even rural and regional sites look a bit easier sometimes, I reckon, versus fighting with the body corporate. But yeah, certainly from our application point of view, a battery back charger would make a lot of sense.
So finally, what's next for eLumina? Beyond the D3, the DS400, what's next?
So, I mean, at our heart, we are a battery company. So we do also have standalone battery products, which we would also sell in support of EV charging, even if it's not our own EV chargers. So we do have a range of battery products that we do sell, and we also work in projects with commercial customers where they just want to put in a battery to achieve one or more things. So reduce their peak demand charges from their operations, to allow them to buy electricity when it's cheap and then use that during the day when it's more expensive. So they reduce the overall cost of their electricity. And last but not least, coming back to the topic of energy trading and arbitrage, they could actually use a battery as another revenue source. So that's something that we're dipping our toes into now. And we see that as being another business avenue for us to go into that BESS only market. And looking at coming up with sort of, let's say, original concepts or designs around battery back charging. So I think we talked earlier about the fact that you could have a separate battery, a bigger battery connected to a traditional direct-to-grid charger. So we've come up with a concept design for just that, like a 5 megawatt, 10 megawatt hour battery coupled with a megawatt charging system. And that would be on a skid-based and containerized solution. So it would be portable. And so you could put it on the back of a truck and take it around to a mine or a port or somewhere else where they've got really, really, really high power requirements for vehicles or frequent needs to charge their vehicles. And even though obviously a 5 megawatt battery needs a much bigger power input than 70 kilowatts for a D3, comparatively speaking, a site like that is already going to have a lot of energy being used and already have quite a large grid connection capacity. So relatively speaking, they can provide more power to charge a bigger battery, but it still means they don't have to get a bigger transformer and wait 2 years for the utility to come and put it in for them. So they're some of the extensions of what we're trying to do with the D3 and the DS400 to meet a few more niche type avenues. So we see ourselves as being able to come up with sorts of ideas and concepts and try and commercialize them for these different types of applications.
Wow. Oh, look, I'm really impressed with the way that you're helping regional and rural Australia extend their EV network through energy storage and fast charging. That's fantastic. I'm sure I'll look forward to plugging into one of those one day when I get out back. But yeah, thanks so much for coming on the show and telling us all about eLumina's products.
No worries, Glenn. Look, I really appreciate the opportunity, and it's just good to have a conversation about it and get some of these ideas out there. And for people listening to the podcast, just letting them know that there are solutions out there that might not be immediately obvious, but could certainly be of benefit to a lot of people.
Cool. Well, I'll let you go, and I'll just wind up the show. So thanks once again, Jason.
Thank you. Well,
there we go. That was Jason Venning from eLumina. really fascinating concept, and great to see an Australian company coming up with these solutions to help not just regional and rural Australia roll out their EV network, but also businesses, factories who need fast charging and are capacity constrained, and a little bit of a sweetener with some arbitrage on top. It's a great combination. Anyway, thanks everyone for watching another Toolbox Tech Talk, and I'll see you, well, me or DJ Glenmo, next Sunday, 1 p.m. Australian Eastern Standard Time. Thanks. Check it.